Hi, this is Goodwin. Today we are going over how to use trigonometry to calculate angles. The objective is that I could use trigonometric ratios to find missing measurements in right triangles. Remember, to be proficient in this objective, we want to be at a level 3. So you can use trigonometric ratios and their inverses to solve for missing parts in triangles, given a compound figure with multiple triangles. So as a little detour, let's recall some inverse operations we already know. So the opposite of addition is subtraction, and the opposite of multiply is division. So if you wanted to undo two terms being added together, you would subtract one of them. And if you want to undo some multiplication, you would divide. Here we are taking the sine of our angle to get a ratio of opposite over hypotenuse, cosine of our angle to get a ratio of adjacent over hypotenuse, and tangent of our angle to get a ratio of opposite over adjacent. But what if we just wanted the angles in here? Luckily for us, there are some inverse functions we can do. So let's look at just sine here, and let's say we want to take the inverse to find the angle. The inverse of sine is arcsine. So if we are looking for our angle, we'll take the arcsine of opposite over hypotenuse. Okay? So if you're given the length of the opposite and hypotenuse, you could take the arcsine of that to find your angle measure. The same thing works with cosine. So let's say we want to find the angle here. We're going to use arccosine. So if we are given the adjacent and hypotenuse, we could just do arccosine of that ratio to get the measure of our angle. And once again, if we are given the opposite and adjacent, we can use arctangent to find the measure of that. So our reference angle will be equal to the arctangent of the opposite over adjacent. Sorry about that pen, guys. Okay, hopefully that's a little easier. You might also see this as like a sine of not your angle of opposite over hypotenuse. Or you might see this sine with a -1 exponent here. And same goes for arccosine. You might see arc a cos. It's not the right pen. Of adjacent over hypotenuse. Or you might see cos to -1 of adjacent over hypotenuse. Tangent, similar, a tan of opposite over adjacent, and or tangent to -1 opposite over adjacent. Okay. So we only use inverse trig when we are trying to calculate the desired angle. So if you want an angle, then you use these functions. Otherwise, you use regular trigonometry. So let's look at some examples now. Okay, so make sure you have your calculator in degrees mode. So make sure degree is underlined. Okay. Example 1, we want to find the measure of the indicated angle to nearest degree. So we are looking for the measure of this angle here. First, we need to identify what sides we are given. We have our opposite, which is 17, and our hypotenuse, which is 38. Next, we select the correct inverse trig, and because we have opposite and hypotenuse, we're going to use arcsine. So our angle equals arc sine of 17 over 38. Make sure you plug in your sides correctly. And then you just throw that in a calculator. So here I'm going to press second and sine. Now this calculator uses this notation, so be careful here. 17 divided by 38. Don't forget to close your parentheses and hit enter. We get 26.57 rounded to the nearest whole degree, so that will round to 27 degrees. And that's it. Let's try another one. Here we want to find the measured indicated angle again, right here. If we go across, this is our opposite, and this is our adjacent. Opposite adjacent means we use tangent, so the angle is going to be equal to arctan of 7 over 24. It's opposite over adjacent. Once again, plug that in. So second tan 7 divided by 24, close parentheses, gives us 16.26 to nearest degree. That's going to be 16 degrees. And that's it. Example 3, same thing. Find the measure of the indicated angle to nearest degree. Here, this is our adjacent side. This is our hypotenuse. Adjacent over hypotenuse is cosine. So to solve this, we have to use arc cosine. So arc cosine of our adjacent, which is 26, over our hypotenuse, which is 42. Second cos 26 divided by 42, close parentheses, enter 51.75. That's going to round to 52 degrees. Let's do one more example. Now, once again, we need to find the measure of the indicated angle to the nearest degree. This time we have all three sides. This is our opposite, this is our adjacent, and this is our hypotenuse, when this is our angle. So we can just pick any two sides to solve this. Let's go with opposite and adjacent. I'm going to use tangent, or arctangent. So arctan of 39 over 30. Plug that in. Wait, I can read. That's 80 degrees, not 30. Second tangent, 39 divided by 80, close parentheses. That is 25.989. That's going around to 26 degrees. And just for good measure, let's do arc sine. So arc sine would be opposite and hypotenuse, so that's 39 over 89. Arc sine, 39 divided by 89, close parentheses. As we see here, 25.989 again, which is still rounds up to 26 degrees. And why don't we do cosine as well? So arc cosine be 80 over 89. Yep, 25.989, which rounds to 26 degrees. So you can use any pair of sides as long as you set it up correctly. That is all I have for you today. Have a great day. Bye!